What if everything you thought you knew about reality was wrong? What if the world we see, touch, and experience is not as solid and unchanging as it seems? From a young age, we are taught that reality is fixed, a concrete backdrop to the events of our lives. But what if this is just an illusion, a convenient simplification that masks a far stranger and more wondrous truth? Quantum physics, the study of the universe at its smallest scales, challenges our everyday understanding of the world. It reveals a realm where particles can exist in multiple states at once, where cause and effect blur, and where the act of observation seems to shape the very fabric of existence. This is the quantum revolution, and it invites us to reconsider everything we thought we knew about the nature of reality. The journey begins by questioning our most fundamental assumptions. Is reality an independent, objective entity, existing separately from us? Or could it be that our consciousness, our very act of observing, plays a crucial role in shaping the universe we experience? At the heart of the quantum revolution lies a profound departure from classical physics. In the familiar world of Newtonian mechanics, objects have definite properties and follow predictable paths. A ball thrown into the air follows a parabolic trajectory, its position and momentum determined at every moment. In the quantum realm, however, this certainty dissolves into a sea of possibilities. Quantum particles, such as electrons or photons, do not possess definite properties until they are measured. Instead, they exist in a superposition of states, a kind of fuzzy cloud of potential. Imagine a coin spinning in the air, neither heads nor tails until it lands. Similarly, a quantum particle exists in a blend of all possible states until an observation is made. This inherent uncertainty is not due to a lack of knowledge or limitations in our measurement tools. It is a fundamental property of the quantum world, a feature woven into the very fabric of reality at its most fundamental level. Perhaps the most famous experiment demonstrating the bizarre nature of quantum reality is the double-slit experiment. In this experiment, individual particles, like electrons, are fired at a barrier with two narrow slits. Behind the barrier lies a detector screen that records where the particles land. If particles behaved like tiny balls, as we might expect from classical physics, we would expect to see two distinct bands on the detector screen, corresponding to the two slits. However, the results reveal something astonishing. Instead of two bands, we observe an interference pattern, a series of light and dark fringes, as if the particles were waves interfering with each other. But how can this be? Each particle is fired individually, and it must pass through one slit or the other, right? Here's where things get even stranger. Even when we send particles through the slits one at a time, the interference pattern still emerges. It's as if each particle somehow travels through both slits simultaneously, interfering with itself. Section 4. Wheeler's Choice, Rewriting the Past. The double-slit experiment already stretches our understanding of reality, but physicist John Wheeler proposed an even more mind-boggling thought experiment, the delayed choice experiment. This experiment takes the mystery of the double slit to a whole new level by introducing the element of time. Imagine a modified version of the double slit experiment where we have the ability to choose whether or not to observe which slit the particle goes through, but we delay this choice until after the particle has already passed through the slits. In other words, we decide whether to look back in time and see which path the particle took. Astonishingly, the results of the delayed choice experiment suggest that our present moment observation can influence the past behavior of the particle. If we choose to observe which slit the particle went through, it behaves as if it definitely went through one slit or the other, producing two distinct bands on the detector screen. But if we choose not to observe the path, the interference pattern re-emerges, as if the particle went through both slits simultaneously. Wheeler's thought experiment raises profound questions about the nature of time and the role of observation in shaping reality. Could it be that our conscious choices in the present moment have the power to reach back in time and alter the past? Section 5. The Quantum Draft, Reality in Flux. The mind-bending implications of quantum experiments like the double slit and Wheeler's delayed choice suggest that reality is not the fixed, objective entity we once believed it to be. Instead, it appears to be more like a fluid, dynamic process, a kind of quantum draft that is constantly being written and rewritten. Imagine a writer working on a manuscript. The story is not set in stone until the final draft is published. Similarly, the universe, at its most fundamental level, exists as a superposition of possibilities, a sea of potentialities waiting to be realized. It is the act of observation, the interaction between observer and observed, that collapses these possibilities into a single outcome, bringing a particular reality into focus. This is not to say that the physical world is merely an illusion or a figment of our imagination. Rather, it suggests that the reality we experience is an emergent property, arising from the interplay between the quantum realm and our conscious observation of it.